So next we will see the program for Simpson 3/8 rule. So it is like h by 8 y0 plus yn plus 2 times all multiples of 3, like y3 plus y6 plus y9 plus etc, plus 4 times other terms y1 plus y2 plus y4 plus y5 plus y7 plus y8. This is the equation, so we need to write a code for that. So we'll be starting with this is 3. Okay, so I'm considering all these variables. Then h is b minus a by n. Then we need to calculate these terms. So I'm initiating the function with this is initial value, and we need to add all the other terms. So I'll be starting with 1 and with a step size 3 up to n minus 1. So I'm adding, I cannot do that because I have to skip the each third term y3, y6, y9. So I cannot continue with even terms and odd terms. So one possibility is I had to consider entire series and skip every third term. So that is a simple possibility. So I had to consider all the terms. So then I had to use an if condition. If I by 3 equal to 0. So I'm considering an integer division here. There is no real number division. So I have to look for the remainder. Select if mod mod I comma 3 equal to 0. So if this condition, if the remainder after division with 3 is 0, then we have to take the quotient 2. Y is equal to 2 star f of a plus I star h. Else y is equal to 3 star f of a plus I h. And if and end 2. That end 2 comes in the next line. Then at the end we have to write I need to define the function again. Cannot update again. But the problem here is this modulus operation is a very costly operation. That means internally it does too many calculations. Like what actually happening here is it takes I minus integer part of I by 3 star 3. Let's say your I is 5. What happens here? 5 minus integer part of I by 3. 5 by 3 is 1 point something, 1.666. I'll be left with integer part of it 1 star 3. Otherwise, to be precise, integer part of 1.666 star 3. So this becomes 5 minus 1 star 3, 2. So at every level we have to perform these many operations: division, integer conversion, multiplication, subtraction. 1, 2, 3, 4 operations. After all those 4 operations, a comparison operation. 5. Then it does these things. So it takes too much computational time. So to avoid that, since we are dealing with consecutive numbers, it is more convenient to split this for loop or do loop. So we can consider each and every term independently in the series. So I can write here like do I is equal to 1 to n minus 1 with a step size of 3. So then I will consider y1, y4, y7. I'll start with 1. Next number is 4 and the next number is 7. So do I1 to n minus 1 with a step size of 3, y is equal to y plus 3 star f of a plus I star h. Then do I is equal to 2 to n minus 2 with a step size of 3. Y is equal to y plus 3 star f of a plus I star h. Then the multiples of 3. Do I is equal to 3 to n minus 3 with a step size of 3. Here it is 2 star so if I consider all the series separately, the number of loop operations are the same. I will be considering all the numbers from 1 to n minus 1. Number of loop operations are same, but simply I am avoiding all these 5 operations during modulus with if condition with modulus operation. So I can simply avoid this. My code length increases, but computation time reduces. Okay, check that also. So instead of these lines, I am writing since we are fixing the step size, I have to go up to the last term. The same loop 1 to n minus 1, starting point and step size are changed. Okay. So with that, Simpson's rule is over.